Hello, everyone. I'm Thilo from Parashift. I will give you a talk today on how Parashift is using GCP to solve document extraction. Probably that topic should normally be presented by our CTO, but he couldn't make it. So we asked our CEO, who couldn't make it. So we asked our head of machine learning, who's on vacation. And so, well, basically today you're stuck with me, a person from the business. I got like all the information I need, hopefully, but if the questions afterwards in the tech talk go too deep, I most certainly will not be able to help you. But I hope I have some nice graphics to show how we scaled and did the architecture and use all the Google services in the back to give you all the insights you need. So Parashift. Parashift was founded when our CEO and CTO, they were searching for a plug-and-play document extraction API. So they tried to extract some basic data like the vendor or total amount, line item, stuff like that from an invoice. And they thought this problem is age-old and there's more than enough OCR solutions on the market. So they'll just buy one and plug it into their accounting service they were building up in another startup, and they'll just go. Yeah, the bad thing was they didn't find any OCR service that was actually matching their needs. Like there were these classical legacy OCR solutions which you had to install on premise, put in a lot of consulting work to get it up and running, and then put more consulting work in until you get halfway satisfying extraction rates. And they said, yeah, well, that should be a lot easier. They want this plug-and-play document extraction API. So since they only had one startup at the time, they just founded the next startup, and that's basically us. Today, our vision looks a little bit different. We want to create a platform for document extraction, but also classification, which is super accurate, fully autonomous, and almost free. So get the human out of the loop. If you have an invoice, if you have a contract, if you have a correspondence, you want to upload it somewhere, and you just get the data back in a structured format. And you don't have to see if you need to correct anything. It just works out of the box. Like, that's what we are working towards. We are not there yet. Otherwise, we would be a little bit bigger. But yeah, that's more or less our vision. So Parashift, we are a team of 25. We're situated near Basel. As I said, founded in 2018. We have a lot of machine learning engineers and developers. So with me, you've got the head of business development. But to be honest, like I'm the only person in my department. So not much of a head there. But yeah, we take the money we have and the resources we have to really create our technology and go further with it, because we believe that if we deliver a great technology, if we deliver a great product, it's way better than having like 20 salespeople. What is enterprise content management? I just want to get you all on the same page. So basically, with enterprise content management, classically it's mailroom solutions. You get a lot of inbox, email, post, emails, all kind of documents. You have accounts payable, this classical process where you want to extract data from an invoice, automatically book it, have a workflow for people to check and validate it and stuff like that. So basically, ECM, most of the times it has these three components. It has the input and capturing part, where you receive new documents and you need to classify them. What are the documents? And based on this classification, you need to extract the most important data. Then you have some workflow a lot of the times. You need to work with the classified document and with the data you extracted. You need to either automatically book it, or you have a human interact with the data, something like that. And then in the classical sense, you have the storage or the archive, where you archive a document for a certain period of time, where the ERP system and other system can access it, and where you can maybe also perform like data analytics based on the document data and all the stuff on that. And what I want you to understand is, like, this is not always a linear process. A lot of the time you capture it, you directly archive it, you give it into a workflow, maybe it's moved into another. But like in a classical sense, it's input, workflow, and archive. And the better you perform the input and capturing part, the more data you get structured automatically. The easier it is to automate the workflow and the storage. If you capture all the data here correctly, you can automate the workflow, you can automate the storage. You don't need human interaction in these two anymore. So our goal is to make life in this area a lot easier for all businesses, for every developer who just wants to maybe develop a cool app and thinks, now I need one freaking document from a customer, how to get the data out of it. And then he has to start using machine learning and he has to set up something himself, and he just thinks, why, oh God, why is not a very simpler solution to just extract a little data from a document? I mean, if it's a form, yeah, like very structured, that's easy, but I'm talking unstructured data or documents that come in a little bit different every time, and you need to set up so many rules, and it's just annoying. So how are we doing it? Or at this point, I just want to give you one quick peek into the application so that you just understand what is happening. Just 30 seconds, and afterwards, maybe everything will be clearer. So when I'm talking about classification, extraction, everything, I'm talking about you have a document like a correspondence. The machine knows that it's a correspondence based on how many other correspondence it has processed in the past. It knows what to look for in a correspondence, so it classified it as a correspondence. And you have certain fields and data that you want structured out of this correspondence. For example, here, you would like to get the sender who sent the correspondence, but you would also like to get the receiver who actually receives the correspondence, and then maybe some general information like the subject or the date or a contract number. So basically, this is like 15 seconds presentation, that's it. That's everything you want. And to get there, what we are doing is like 4 different steps. First, if we receive a new document, we have some pre-processing with the image we have to do. So clean up lonely pixels, disqueue it, see that it's not rotated 90% or 180 degrees, so it's standing on top. Of course, we need to do like all the software, what I'm describing here, generally speaking, a lot of people out there call it OCR software. They are not they don't mean the OCR engine. Everyone in here most likely will know the difference between OCR engine and what we are doing, but business people say OCR software and they mean everything. But in this pre-processing step, we actually do the OCR, also like ICR, reading out barcodes, layout. So we gather all the ground information we can get from the image and from the document, be it a PDF or whatever, to later perform our tasks in a proper way, like first step. Then we have separation. So customers, a lot of the times, they upload 20 pages, and the first 3 are an invoice, the next 3 are a delivery note, the next 5 are something different. And so you need to find the beginning and end of the documents and automatically separate the documents. This, by the way, is not yet in the platform. I'm just showing it because we will do it. But it's an important part in this whole setup. Also, if you look at the workflow from a customer point of view, sometimes they have these scanners and they don't want to scan each document, say scan, document, scan. They want to take the whole batch, put it on a scanner and scan it. Afterwards, as I said, classification, what kind of document is it? And then the extraction of text fields, dates, amounts, addresses. You want to maybe interpret certain sentences and find cancellation information out of sentences or whole text blocks, tables, detect signatures, stuff like that. And basically, like, this is the hardest part of everything in here, from our point of view, of course. This is where we put in all the brain and what I will show you later on, how we automatically train on this, how the architecture is built towards doing this. Which challenges did we face? So when we developed the platform, first we started locally, but at some point we decided to create a product, create a new startup, and scale it. And the challenges we faced was, one, resources. I don't know if you've ever seen something like this or something like this. Like, this is a freaking expensive piece of hardware that's able to scan 730 pages per minute. It's a scan street. And big companies have oftentimes multiple of these. So what they do, they get all the inbox, the post, and there's still a lot of paper around. They get it in the morning, 5 o'clock, because they have special contracts with Swiss Post to get it extra early. They get it at 5, and they use these scanners in 2 hours to scan everything. These don't run the whole day. It's about speed. You want your documents in your system as fast as possible, so your workflows can start as fast as possible. So what does that mean from our point of view? There's like, in the whole Switzerland, there's like a time frame between 5 and let's say 9 o'clock where we suddenly get a freaking huge amount of documents all at once. And we need to do pre-processing, we need to do all the data extraction and classification, and after this time frame, it's just going down again. So if you have an on-premise installation, what you do, or what you did like a couple of years ago when cloud and everything wasn't, if you were working with VMwares and stuff, you try to give the machine doing the OCR and everything, you try to give it enough resources that it was working fast, but not too much because it was laying idle the rest of the day. And you had certain documents with higher priority, which needed to be fast and all this kind of stuff. And if we go in the cloud, if we are a cool startup, you can't say your document is now being processed 10 minutes. You have to wait 10 minutes until you can see results. We block certain use cases. We just, like we need to have scalability up and down at the back. Challenge 1. Challenge 2, compliance, data protection, and security. A lot of local governments or organizations like the EU or the US or whatever, they have special law in place for all that. I mean, I don't have to tell you about data protection and stuff. But with documents, of course, there's a lot of the time the sensitive data on there. And as soon as this data leaves certain country borders, imaginary country borders, it gets a problem. And in the sales process, you are stuck half a year with some compliance department talking about nitty-gritty details. So if we want to scale this platform, this product worldwide, we would need a provider or something where we can just scale it into new compliance zones, into new countries, and just say, okay, you want your data only stored in the European Union? No problem. We'll set up a data center there. You want it in Switzerland? No problem. We set it up. Challenge number 3 is the complexity of the whole business. Like, as I've said, we started with invoices because every OCR software is starting with invoices. Invoices are freaking boring, but it's the one use case really every company has, and the one step into and say, hey, come on, let's work. We'll start with the invoices, and afterwards we'll do lots more. And a lot of the times you stop after the invoices because the company has their mind already somewhere else. But we started with invoices. But now we wanted to go further. We have delivery notes, which are very similar. You have kind of the same data. Like, this is not all the data we extract. It's just an excerpt, an example. Like on a delivery note, on an invoice, you need the sender, the vendor, the invoice date, invoice number, maybe total amounts. On a delivery note, you have exactly the same. You need the vendor, but the delivery note date and the delivery note number, and most of the times you don't have total amounts. So this is something you could standardize. An invoice, every company has invoices. Everyone needs the same data out of it. You could standardize that. That's what the little S in our little Parashift symbol should indicate. Delivery note, we could standardize that as well. Correspondence, we could standardize that as well. Just the 4 fields I showed you, like sender, receiver, subject, date. And if they want something special, they should be able to do that too. For example, here's a document type that I don't know what company wants to extract data from, an eye color inspection report, where they also need the sender, the document date, some total amounts, the eye color of the person filling it out. I don't know why, but they want it. It's on the document. They want it extracted, and the name of the patient. So as you can see, like there's similarities to the correspondence delivery note and invoice, but like also some crazy shit that we couldn't possibly put into our standard for. So we searched for a way to solve this complexity, to be able to serve customers who just want invoices, delivery note, and correspondence, but also serve a customer that wants something special. And I can tell you firsthand, I mean, I tried to sell it without this, and it didn't work. Like customers were saying, yeah, it's cool that you can process invoices, but I want this. I want one field more on an invoice. I'm a very special customer. On my invoice, I want this. Or I have a very special form. If I already use you, I have this one vendor policy. So if I get a vendor for OCR, you also have to do this. So we adapted, and well, I told you our vision. We wanted to go here as well. But this complexity, we knew that we had to tackle it one way or the other. And that's basically like the solution for these was for us, yeah, let's go to the cloud. Like, I mean, it wasn't a discussion. It was always, of course, we would go to the cloud. We are a startup founded 2018. We wouldn't deliver an on-premise solution. But it helped us with the resources. We could scale up and down in the back like we wanted to. And I will show you in the architecture. It helped us, or actually the solution wasn't only the cloud, but it was especially Google for compliance, data protection, and security with different compliance zones. We are now in a position to easily deploy into another compliance zone. And if a customer should want it, we can go elsewhere. And also, like, they have a Swiss compliance zone, which is great. And challenge-free, the complexity, we were able to tackle that as well in the cloud. The cloud is not the solution to solve this, but it gives us the tools to tackle the complexity. So it's just a road to the solution, not the solution itself. That's the little asterisk. But for the other two, it was a place of magic and wonder, the cloud. So our journey to the cloud was actually like 2017. We started with some local research on local hardware. We developed a machine learning model for invoices. We had we had different models, one for header information, one for line items, because tables are very special and stuff like that. Then again, the same year, we already started to develop the whole stuff on Kubernetes, because we knew we wanted to go there. The other startup was using the same as well. So yeah, or at that point, we were still, I think, one startup. So we went to Kubernetes, and 2018, we started with the search for a cloud partner. But there was not very much choice on the Swiss market. If you wanted Kubernetes, there wasn't like this big list of vendors delivering you Kubernetes with a Swiss compliance zone, especially if you are a small startup with basically no money. I mean, we had money, but like you cannot spend it everywhere. There were vendors around which would go to the big banks and insurance companies and sell them Kubernetes in the cloud, with a retainer of 200 person days just to set it up. So yeah, I mean, we couldn't really afford that. So we went with a smaller local vendor first, but we had a couple of hiccups. They weren't quite familiar with Kubernetes at the start, and it wasn't quite working out. So in 2019, we migrated to the Google Cloud Platform Swiss compliance zone. And my CTO said this. He actually looked it up. It was the 12th March of 2019. And he said that was the launch date or something. And he said, again, that we are probably one of the first GCP customers to go live in Switzerland. So hooray. And 2020 now, like what you've just seen and what we will be launching in 2 to 3 months is our completely reworked platform, where I will show you, like, here we had a version 1, like version 0, version 1, and now we are going to our version 2, where there's a lot of different things, a lot of learnings inside, and I will show it. Good. But sometimes you still need local computing power. So this is actually an image from our office in Sissach, and there's like these two sick gaming racks. Like it's really each of these has a GeForce 1080 Ti, so the top-notch graphic card 2 years ago in SLI mode. And I don't know what here, like Republic of Gamers. If you would look into our server room, you know, you would think someone's like really hard gaming then. And on these, like I really like the setup. We even got this glass panel because it was cheaper in a bundle, and there's Linux on it. You know, like it's so. I don't know. You can't game on that. It's for machine learning and for training around a little bit and having resources at hand. But shame. So, how are we set up? Of course, we have a microservice architecture for machine learning. Yeah, of course, we're using Python in the backend. For our front end that you've just seen, we're using Angular. I have to point out, I don't know why, but we have a one-page application. Maybe that says something. And for the backend, we are using Ruby. Messaging, we have actually like 3 different products. We have RabbitMQ, Redis, and we also use Google Cloud PubSub at some points. But the problem with this setup is that it's too diverse, and RabbitMQ is like it needs a lot of maintenance and it's complicated, and we are actually on our way to maybe get rid of it and go fully Redis or Google Cloud PubSub where it actually makes sense. The database is a PostgreSQL. In the beginning, when we went with Google, we actually deployed the database ourselves in pods ourselves. But we quickly realized that it was way easier to actually use Google Cloud SQL, is it called, I guess. So today, even though it's a PostgreSQL, it's also hosted with Google, and yeah, we're happy with it. As storage like the storage you will see later, also like a couple of functionality there. For one, we need to persist the documents that we receive. We need to persist different previews and like all kinds of stuff related around the document. But what I will show later, and what's more important, we also need to persist all the data we need from the machine learning and have a flexible way to train and learn from this data. So we use Google Cloud Storage for that as well. Logging, monitoring, Google Operations, machine learning training. We are currently on the path to migrating to Google AI platform to train there. So currently it's also some pods, base pods that are running there. And communication, we are working with HTTPS requests. I should also put that in here. I don't know. I mean, I know how to get a REST request and everything, but like, I hope someone said, "Oh, that's cool." So what are we doing like with our microservices? Here are some basic examples for what we have actually workers in place. Like we have a worker that does nothing else than generating previews. Take an image and scale it down, scale it up, scale it into formats that later on the machine learning workers or extraction workers can actually use. An OCR broker, which basically does, in our platform, you can configure what kind of OCR engine you want to use. Like we have a local one, Switzerland only. Then we have one for EU only, and sometimes customers want us to use us on premise. We have a solution for that as well. If you're interested later, I could say 1 or 2 words to that as well. Now I'm saying that we are not like, sometimes for banks and insurance companies, you need to have an on-premise solution, and so and if they use it on premise, we can't use our regular OCR engine because it's in the cloud. So for these customers, we can say, yeah, just use a tesseract, a local tesseract. Then, for example, a regex extraction. This has nothing to do with machine learning. This is like the most stupid extraction method there is. Look for a number with a certain regex and find it. But come on, if you need an IBAN, And yeah, with regex, you can identify all the IBANs on the document. You can still use machine learning to see if it's the right IBAN, if the surroundings are correct and everything. But just to identify, is this text an IBAN? Yeah, use regex. And we also have key value workers. Look for word X, give me the word right of it. Stupid, but effective, and like very simple to set up, and very good for customers. And you can extract forms, like static forms. If you have regex and key value, most of the time it's working. And yeah, so but basically, like there's in the back, there's always like a base amount of these regex extraction or OCR brokers working, and if we get a lot of load, we just scale up. If all the work is done, we scale down again and go back to this base amount to, yeah. So what happens is if you upload 1,000 documents, like in like 10 seconds, the first one will be very fast processed. Then we need like 2 to 5 seconds to scale up, and then the rest will also again be processed very fast. So yeah, if you have a synchronous use case where the user takes a smartphone picture and is actually waiting for his result on his screen, 2 to 5 seconds, still too long. But yeah, we're working on that use case as well. Yeah, deskewing, as I said, see if scanners a lot of the time, especially the crappy multifunctional printers you scan documents on, they have a slight skewing, and you just need to deskew it. Yeah. Rotation control, as I said, also a couple of them. Like behind these two, there's machine learning, but it's not extraction machine learning or for classification. It's just something. We had a couple of our employees, like couple of days actually sitting there and drawing boxes on skewed documents. What is the right angle to automatically deskew it? And now we have a model that does that for us. And then we have the machine learning extraction workers. Yeah, like document in, values out. Like that's nothing standard about that. That is absolutely not working. We like all this, you can scale up, like this is basic stuff. It's easy. Our machine learning extraction, that's nothing easy is about that. You remember the complexity about the different fields, different document types, etc. Like if you would start with just deploying this, you would have for each different field, each different customer, you would have your own machine learning or ML worker in the back consuming a lot of data, and like this is just not going. So back to this challenge 3, the complexity. How we started with our version 1 was basically, as I said, we created one machine learning model for invoices to get sender, invoice number, total amounts. At that point, when we created that, we were thinking we will do invoices, maybe credit notes, like just 3 or 4 document types is enough, until we realized it's way cooler and there's a way better use case if we just extract every document type, if we make it easy for the customer. So this approach works really, really well until a certain point, and then it stops working well, and then you need shit ton of data to get this better and better. And at some point, we realized like that's not the right way. So it does not scale. It's too slow. We need too much data. It's not easy to combine. Like as I said, for a correspondence, you need the sender. For this, how did I call it? eye-color inspection report, you also need the sender. So if you would set up an own model for this, you would start training on a sender again, even though you already know how to get a sender based on invoices, delivery notes, correspondence. The place where the sender is sitting, the address, it's always the same. So yeah, why not do this? You create one model per field or field type or field set that you want extracted. So this is the version 2 that I just showed you, and that I will show you. Like we don't have one model per document, but we have one model for the sender address, which can be reused in multiple document types. It makes it super easy for us to set up new document types, to mix Parashift standard stuff. So like the sender address is something that we are training for our customers. We are offering a full service where we have employees that actually do the data correction. 2 reasons why we do this. 1, it sells. Customers like it if they don't have, like, if you start talking about extraction rates, we can extract your data 80% correct. You say 80% is cool, the customer says, yeah, but what about the other 20? And then you start a discussion about extraction rates. And, you know, salespeople, they lie. And you're sitting there and they say, yeah, your competitor promised me 95%. And I say, yeah, I could promise you that as well, but like, show me a nice sample of all your documents, give me like 5 days of work, I'll compare it, I'll take the ground truth, and then we'll see, and no one wants to pay for that. So it's better to sit in a sales call and say, yeah, but I can deliver 98% on field level. Yeah, how? Yeah, we have humans in the loop, like human in the loop, the next. Also, AI. Now, I said it, like, we have an AI document extraction, right? Marketing, hooray. Hooray, Mattia. Where was I? Yeah, so we have this full validation option where we extract all the data and we learn, like the sender, document date, document number, total amounts, we learn this kind of stuff, also the subject, but the customer can learn the eye color and the patient name himself because it's not interesting for us to make a global standard for this. Good. I'm nearly at the end. Sorry, I talk too much. Business, yeah. So what you can see here, like, we have the receiver and it highlights all the data that we need. And this extraction interface, it's not only to show me how good the machine performed, but it's also for the user to, or us to tell the machine where it didn't perform as well. So the subject was only 88%, it stopped because it's yellow, I need to look at this and correct it. And what I can do is just, I can go on the document, mark it, and he says, wait, it's green, it's super. And he will remember the position where he found it. And all this data, where have you found it? What was the structure? What is the text? What's some layout, like font and all this stuff, we are saving in the background to this document to train this subject extractor on this kind of data. This one user interaction is the basis for all our training. And of course, a regex extractor, like, we can't train it. It's a regex. It's 100%. Either it works or it doesn't. But this machine learning stuff, yeah, actually good. Like this contract number here, that's key value. Look for contract number, give it right. It just, you can show it nicely. It only has 93% because the OCR was maybe not as good. Yeah. So now the image you all have been waiting for, and I'm dreading because I have no idea. So what we are having is basically with Google Cloud Platform 2 Kubernetes clusters currently. One for the platform where there's stuff like the user interface, identification, backend, API, the webhooks, like all this kind of stuff. Then we have a second cluster just solely focused around the machine learning. And like, there's no technical reason why we have 2 clusters. It's more an organizational reason. Like, this is development, backend and front end, and this is our machine learning department. And so, yeah, it's more organizational. It could also be one Kubernetes cluster, but, well, we've set it up like that. We have GitLab as a code repository. All the changes are logged there, documented, etc. And we build our images in GitLab and push them to Google Cloud, Google Container Registry. Like, not only the machine learning images, but all the images. But this picture more focus on how we do machine learning. So, as I said, we save the position, we save the text, we save all the data that the user entries inside of these field or field type containers on a Google Cloud Storage. We have like folders here for images, models, metrics, ground truth, data, like all this machine learning stuff. And so we save this ground truth here. And once either we have enough documents to warrant a retraining, or we reached a certain number of documents, the backend actually has like this little intelligence. If a user starts with a new document type, he uploaded his first 5 are annotated, everything is well, he starts his first training to give the user quick results, something to look at. But if he has thousands of documents or fields in his training, he just does it once a day. And for our standards, we also use it once a day. But so this triggers like a new training our training orchestrator, we are going here more to Google AI platform. He will take the images from the Google container. He will fetch all the training data we saved over the day inside of these fields, do his training magic, and send the new model back to the Google Cloud Storage. And tells the backend that the new training was performed. And what we are then doing also is benchmarking. We are looking if the new model performs better than the old one, then we decide to keep it or we just throw it away. Or not throw it away, but don't publish it. And so in the machine learning, we have, currently we are using Google Cloud Run for these machine learning workers. Again, they can be scaled up and everything. But the problem with Google Cloud Run here is that you're limited to 2 gigs of memory. And if you use machine learning, especially for our standard document types, a lot of times we are above 2 gigabyte. And so we're looking into migrating away from Google Cloud Run back to bare pods. Also, I don't know what bare pods are. I'm supposed to say it. And what we are doing is like the newly trained model, we save it with a daemon set inside of the the models on an SSD, so that the machine learning worker is actually very generic. Like this is a token type or an object detector or I don't know what. And if we now need data extracted from a document, these workers just take the model from the field they should extract from the SSD, do the extraction work, and then are ready to do the next task. So we looked into deploying one dedicated machine learning pod or worker for each and every field. But if you think back, like we want to scale big, if we have 1,000 customers, each customer has 10 fields, that would mean like such a huge amount of workers we need to have running all the time, because every customer could upload a document at any point in time. So we need a more generic solution. So these generic workers which just take the model that they need, like the model are the ones where we have 10,000 models, but the worker just takes the model he needs, does his extraction, gives the data back, and finish that. And this is a solution where we worked like very closely together with Google also to get something working here, because as again, this is the complexity, and this held us up. Yes, that would be it. Thanks for your time, and if you have any questions, I can try to answer them, or I could give them internally. And and if you are interested in document classification and extraction, Parashift. Good.
When did you start the project with Cloud Run? Because Cloud Run is very young. So when you started, it was the
November. Last 2019 in
March
November.
19.
No, November. The Cloud to use Cloud Run for all of this, we started last November. Yeah.
Okay.
Like the ground foundation for this version 2 was late in November, and everything you see here was done since then. Like the identification and a lot of like user interface and a lot of these identification, we reuse that from version 1, of course. It's the same look and feel, and it's the same authentication. The webhooks are the same, but for our new platform, what we did new is like this, and of course, and the front end, but like a lot of the stuff is kept.
How do you convince your potential customers that their sensitive documents can go in?
Like you have certain laws and regulations in place, and you just need to know your way around it. And for example, if you have a Cloud Act, which is one of the most cited ones, as soon as your customers know that you're working with Google, they say, yeah, it's an American company and Cloud Act and stuff. You just need to have your arguments ready, like they can't actually access the data. We encrypt everything down here. as soon as you're working with any American company, you are also under Cloud Act and stuff like that. So you have your basic pro-con catalog ready. And if it gets too complicated, like we actually had discussions with one of our biggest clients, actually Google was kindly enough to help us there out and go with us to the customer, or just talk to them directly and convince them to use it. So yeah, and for if you have banks and if you have FINMA in Switzerland, like there's no reason to go into a Swiss compliance zone. Like they released something new, I think March or April or something, and yeah. And for GDPR, we have all this documentation ready. If you go parashift.io/GDPR, you get our data contract definition for the customer to fill out, and our technical and organization measures and stuff like that. And you need to have this ready. Like, you're not allowed to waver if a question comes up. You need to have something ready so that you project confidence that you know how the topic works. We know how the topic works, but like as soon as you waver, you know, because the customer is unsure themselves. And
Cloud Act?
Cloud Act?
Yeah, did you say Cloud Act in the first half of what you're saying?
Yeah, it's from the US, or yeah, the US government. As soon as you are working with an American company or something, the American government could try to access your data, which is stored by that American company. And it doesn't matter if it's actually outside the US or inside. And like, there's a lot of worries around that. If your customer has problems with the US, that they are gonna want your data from us. And so, yeah.
How does your system deal with documents with diagrams or something like that? Does it?
Not at all. Yeah, at the moment it's like we tried a couple of models out to just detect pictures and detect these kind of graphics and so on. So I think we could fairly quickly write an extractor to tell you there's a graphic, but not like interpret the graphic actually. Like, we have this signature detection feature or planned where it just tells you where it finds signature and stamps to. We cannot tell you if a signature is correct or not, if it's valid or not, but we at least can tell you, hey, most probably there's a signature or there's handwritten stuff on it.
So there's a possibility that you could do something like that in the future.
Yeah. Like, if we have this, if a customer comes to us and says he wants these diagrams, we look into it. A lot of the times we set up a small project together, proof of concept, we try it out. And then if we implement it, we don't implement it for that customer, but we rather, we write a new machine learning training or worker, like a new extractor, which then is published for every other customer as well. So he could say, I want a new field of the type signature detection. And so that's how you bring it forward, and we don't want to make special stuff for everyone. Something else?
Just a curiosity, but that machine that reads the paper letters that arrive in the morning, actually someone has to open the envelopes and put the papers in, right?
Yeah, but there's machines to open the envelopes.
Ah, okay.
Yeah, like
I was expecting that. Okay.
there's machines to open the envelopes, and there's also
I cannot imagine because everybody folds the paper in a different way, you know. So
yeah,
the machine have really to expect everything.
There's also these ones. They are not for speed, but you put the envelopes in here, and it cuts it, and it presents it here. The operator is sitting here, and it presents it already like open, so that you can just take it out.
Wow. Okay.
This is one touch. It's another scanning process.
I had no imagination something like this.
Yeah, that's a great thing. Like, also, the scanning machines, they are really, really expensive.
There's this magic machine that scans like hundreds of things, like 700 in a minute or something. Yeah. But now there's actually a mistake. How would you find that? I mean, just to correct that? I mean, is that the client's responsibility to kind of find the document and then give you guys feedback that there was a wrong match or something?
So the question was, if you have these fast scanning scanners, how to see if something was scanned not correctly. Like a lot of the time, the physical process is open the envelopes automatically, take out the document, and on each document on the first page you put a barcode. And this barcode is used for separation, because then you can just put the whole batch into these scan streets or into the scanner, and you scan 200 images, and in the end it knows to separate by barcode. But these barcodes are also used, they have a unique number on them most of the time, and later in the workflow, if someone says this document is unreadable, it wasn't scanned very well, you can say this number needs to be scanned again. And the guys scanning, they normally have a short time archive where they keep the physical paper for 15 days or 30 days to then rescan. This is not part of our platform, but just, free consulting. No, sorry. But like there's a whole industry about this stuff. Any more questions?
Do you charge extra for your on-premise deployment?
Yes, yes, and we try to set the on-premise deployment. Yeah. So if we deploy on-premise, we basically just deployed with pre-trained ML workers and like little model how they work each other. It's the same API. So if you would use our REST JSON API in the cloud, it's the same API on-premise, so that customers can decide what they want to process in the cloud on-premise. But we charge extra, and we try to set the price at a limit where like not many customers would actually want it, and we were surprised how many actually wanted it even with this price. And yeah, so it's now something we actually have to deal with. And we have this channel in Slack with us where you can just swear a little bit if you're upset about certain things, and there's a lot of swears about this on-premise installation, because as soon as you deploy on-premise, of course, it makes this a lot harder in the cloud, because everything you develop, you have to think, how would it react on-premise? We already tell our customers, you get, how's it, this Google Crowd, not Kubernetes, like there's this other very easy to run, you just give them a zip and they can run it. Again, no idea. But we say you have to have a Kubernetes cluster, you have to look for it yourself. We give a little instruction, but still, until you have it once up and running, it's quite a pain in the ass. But afterwards, there's like a script where we just can say, hey, he wants a new document type, and we export all this stuff, all the configuration in the back automatically into a zip, give it to a customer, he can deploy it.
How do you find Kubernetes? It's very complicated.
Wrong guy, sorry. I don't know, like, yeah, sorry. Yeah, but like, I'm also in the dev channels, and like we have out of our development team, there's like 1 or 2 guys who do all the DevOps stuff, and we're actually searching for a full-time DevOps engineer to take this into the hand, because for our normal backend guys, like this is, or it's just too big of a topic to do it in parallel. Like UX, we also we have front-end developers, but we're also searching for UX engineer, because next topic where UX is too important to do it part-time. More questions? Like, I don't have to speak. I'm gladly to. No? Good? Okay. So thanks again. If you want to reach out, you find me on LinkedIn. No fancy Twitter, but LinkedIn. And or just drop me an email or go to parashift.io. And yeah, thanks for your time.